Hey folks, this is me, Vishwas Nair. I'm the host of this podcast. A lot of times I realize one thing, you know what? You have to be a machine in order to achieve something more in the world of technology. I think Peter is one of those guys that I always look back at and I always want to be somebody like him. And that's how Peter is all about. So he's so much energetic and also the way he educates people is something that's fascinating for me. And let's just demystify his journey in becoming what Peter that we are seeing today. Let's just get some insights about the tech from his side. And thank you so much, Peter, sir, for being on my show. Means a lot.
Well, thank you for having me. I know we talked about this for a long time, and I had to move it out several times, but I'm super excited to be here. It's always
Sure.
nice to. Well, first of all, I'm actually getting a little bit shy, a little blush here because you're using me as an example. But I think out of what I do and have been doing for so long,
Yeah.
like sharing knowledge, doing public speaking, um, it seems that at some point you become like an example to someone, and yeah, that's another reason why I really enjoy being here. So thanks for having me, I would say.
Sure. So let's just start your journey in the cloud computing world. I want to exclusively start with the experience of being a system engineer. And how did the database journey and all these things land up to you to be a good teacher and an MTT, by the
Mhm.
way? Being an MTT is not just a role of teaching, but it's also about teaching the industry folks. So how was your journey all about?
Well, now you make me feel old because I need to think back about like where my career started 26 years ago. But so indeed, yes, I started as a database management admin. It was well, I think a logical step. So although I've been working in IT for about 24 years, um, my college degree was business management and a specialty in accounting and finance. So I came in with an accounting background. And the funny thing is that whenever I'm like losing points at home, like when my wife gets angry, she calls me an accountant. And that's where I know like, oh, I'm doing something wrong, right? But so the first job was SAP database admin for Procter and Gamble in Brussels, the European headquarters. And it was a good mix between the accounting background that I had from college, together with providing like basic IT help desk support. So that's where I was in that role for about 18 months. And during that 18 months, they actually migrated a huge part of their platform from SAP on mainframe to Windows NT4 server. And since I had some PC background, because during my weekends and holidays, I worked at a PC store, like building PCs, fixing PCs. So that's where I mainly picked up my I think passion for computers at that time. And I already had experience with Windows client, Windows Server, and they allowed me to participate in that migration project. Now it was completely outsourced by IBM, so I could just like follow along, but I couldn't really do anything out of the migration myself. But that's where I was like, I want to be like those guys working in a data center, deploying servers, storage, networking, firewalls. And after I think about 18 months, started applying for um, technical engineer positions in my area. So moved from the big multinational Procter and Gamble to like a small IT shop with about 50 employees, where I was actually the first Microsoft guy. So they built their own point of sale system based on Unix, VEX, VMS systems, and I was like the first hire on the Windows platform, and that also helped me in like really, I would say, building my brand, because everything that Microsoft released at that time, like Windows Server, SQL Server, Exchange Server, I could get my hands on it, play with it, test it out, and then convincing the company like this is the platform that we need to move forward to. And then also they acquired like I think Visual Basic developer team to actually rebuild their system that's been running on Unix to Windows, and that's where I could build like the full Microsoft-based data center. And then from there, moving on, obviously in my experience, then moved to another IT company, worked there for a couple of years, then moved to another IT company, the largest one we had in Belgium, And that's where I started working. So that was around 2006, 2007. And that's where I started working on European projects as well. So although they were Belgian based, they had some interest in working a little bit outside of the country. And that's where I would say my interest for traveling started as well. Because customers are different based on the location they're in. So they can be in the same business vertical, but they need to like take local compliance into account. Sometimes the culture is slightly different. The work mentality could have been different. And that's where, after traveling around for a bit, I decided to start my own company and focusing a lot more on the training part because I liked initially, but I'll share that in another, maybe another call. But initially, I hated being a trainer. I didn't want to follow slides. I wasn't that good in preparing for my sessions, and I just relied on my experience, where I was not really, I would say, presenting as a trainer, but I was presenting as the consultant and talking from my real life experiences. And apparently I did something good because the reviews and feedback was always good. And they said like, yeah, we're learning so much, like really learning from the field. So we're gonna skip all the slides, we're gonna skip all the labs and just talk through like how you would do it. So that's where I decided 2010, starting my own company, initially still attached to that partner company above, but then in 2013 decided to spread my wings and literally start like running my own business on my own and focusing on Azure because Azure was coming up at that time with a good mix of consulting, so Azure deployments, architecting, coaching, and providing a huge amount of workshops. And that got me into Microsoft initially as a vendor, providing workshops for them, for partners, customers all over the globe. Then had a few months as an internal FTE 2016. Didn't work out as planned on either side. So eventually, after not even 9 months, decided to leave Microsoft again and going back to my own company. And then in 2019, around summertime, they started expanding an internal trainer team, and they asked me to join. I went through all the interviews, and I'm in that position now for about 3 years. And a few months ago, they moved me to Redmond. So long story, about 26 years in my career, how
Yeah.
I moved from a Unix mainframe boy into to like a passionate Microsoft trainer, you could say. I think that's a good summary.
Sure, that's a great summary. By the way, that's a very great journey. I to have something like that. So, my next question is all about your first introduction to the world of DevOps. So, what happened on the day that you got into this world of DevOps, and how did it change the way you think today? Because a lot of people, when they talk too much of DevOps, I got fear because I don't know DevOps. But like, what was your
Mhm.
reaction to that?
Oh, it's been an interesting journey. I think out of what I shared, it's probably clear that I've been an infrastructure person for so long, and to me, DevOps was something for developers. Like they were using Visual Studio or any other development environment, and they would do magic, right? And I always thought, like at least to me at that time, that DevOps was like way too complex, way too advanced. Um, Not something I've seen a lot in my career, I would say. On the other side, like after like starting my own company and working a lot more with global enterprise customers, I always had to push back on like the enterprise complexity, like the automation part, where implementations, migrations were still pretty manual, I think. And a big reason was, like I think you mentioned, I was also afraid of DevOps because there was so much around DevOps that it was a huge part on the development side, and I had like no notions at all about developing. But on the other side, I was always interested in that operational side, where my initial steps into to DevOps was moving the existing PowerShell scripts that I had. And I was so bad in PowerShell. I mean, honestly, although Exchange was a big product that I deployed over the years, where as of 2007, it heavily relied on PowerShell, but I was so bad at it. Like even VB scripting, it was always something that that I never really like understood how it actually worked. And at some point, out of actually my last customer before I moved to Microsoft, they were asking questions during Azure workshops about DevOps. So not even Azure DevOps, but just like how can we work better together? How can we collaborate with our developers? And something is not really working out. And that's where I started initially providing coaching on how to like glue the two worlds together. And I didn't have any real experience in DevOps yet, but I just chat like, well, maybe you should get out on a Thursday evening, like a few weeks in a row, and starting to get along with each other. And after so many months talking to the CTO of the company, he was like, yeah, but so what you're technically doing is DevOps. And I was like, no, DevOps, it's too technical. I'm not talking about DevOps from a technical perspective. I'm talking about it from like aligning the culture, making sure that whatever the development team is working on is helping you as an organization, that you're spending money, you're migrating workloads to Azure, because that was obviously my prime project there, that it is providing value to the business. And that's where he said, like, well, I'm going to send you a few YouTube videos and watch them in your hotel, come back tomorrow and tell me like what you've been doing over the last few months, if it's different than DevOps or not. So what he shared was videos from the Microsoft team. So Abel Wang, Donovan Brown, where they talked about this is DevOps about, like providing value to the business. And I was amazed. I was like, oh my God, I've been preaching DevOps without knowing I was preaching DevOps, right? And that's where I started looking into learning more on the technical side. Like, what does it mean to integrate automation? And then finding out that, yeah, the PowerShell scripts or the Bash scripts that I had already, just by gluing them together, stacking them together, I could run what we call a pipeline nowadays, right? Where again, it blew my mind. I was totally amazed, like, oh my God, I can do DevOps. And that's where I started looking into like how can I optimize the DevOps process? How can I integrate the developers a lot more? It's also where I started automating my own lab environments. So before I moved to Microsoft, out of my company was offering like a hosted lab environment. And in the early days of that lab environment, like every weekend, like traveling to a customer location and running a whole bunch of scripts for deploying 25, 30, sometimes 50 virtual machine environments, creating user accounts, everything, where now I could automate all that. And instead of like spending my whole Sunday afternoon or Sunday night, I could just rely on the system and even making it like a scheduled task. Like I need my classroom to be up and running Monday morning, 8 o'clock. And I could just run a pipeline, running a script or a collection of scripts. And now I love it. And over the last 3 years in my Microsoft role, I started delivering the Azure or yeah, Microsoft DevOps solutions training, the Azure 400. And it's one of my passionate domains now. So pretty cool stuff. I could recommend it to anyone. So at first, I think it's scary, and I think it's normal because it's complete. There's a lot of different motions and different parts looking at you like the DevOps person. But once you see that magic, the little sparkle, you could say, I think that's where, for me at least, it became a roller coaster and having fun every single week talking about it.
Sure. Let's just start with your journey as a student that was a professional, this and that. That was crazy amount of journey. Like, everybody wants that. They want to evolve in that organization as a student, as a professional. But you know what? Every cloud, like today, gone of those days, nobody wants to manage their GPUs. Nobody wants to manage their CPUs, by the way, on their cluster. So that's how it is. So I wanted to know, every cloud vendor has their own well architected framework, but I don't know what should be the fundamental understanding of it, because to me, yes, every framework looks the same, and like to me, it's a well architected framework. That's it. So what should be the understanding in order to understand what is there inside a well architected framework from any cloud service provider? Like, what should be the prerequisite according to you?
Well, I think overall, like if you look back and talk about my own experience, for me, Azure started, I would say, like really business focused, not the preview versions, not the early Azure Classic environment that I just looked at and never really used it. But like as of 2012, 2013, I started looking into like the hybrid cloud. And I think one of the baselines for the well-architected framework is fixing the problem that a lot of organizations forget about, like over the last couple of years, because everybody's been talking about cloud, like cloud is crazy, cloud is cool, cloud is high available, and so on and so on. And I think a lot of organizations started jumping onto cloud without looking at all the characteristics or even the specific complexity that comes with embracing cloud, right? Where, yes, it's easy to spin up some virtual machines, there's automation, there's templates. And after using it for a while, I think a lot of organizations started seeing the potential risks of it as well. And not really talking about it from you're doing something wrong, but you're not really like maxing it out. You're not really optimizing the way you're deploying it. Like you can deploy virtual machines, but if you still manage cloud VMs in the same way as you're managing your on-prem Hyper-V, VMware-alike scenarios, I think you're doing it a little bit wrong. On the other end, the last couple of years, it's all about containers, microservices, Kubernetes, right? Where I've seen customers jumping on cloud and using that container footprint as a model, but not always knowing what they were actually getting into. And I think that's a lot of different parts that the well-architected framework tries to help you with. And the nice thing, as you said, it's like nothing Azure specific. It's available with all three primary clouds and probably some other ones as well. But to me, the well-architected is like giving you that foundation, the guidelines, the blueprints, if you want. Like this is how you've been doing cloud for the last 2 years, 3 months, 5 years, maybe 10 years for the early adopters. And this is our manual on how to do it properly, like covering security is in there, building high availability is in there. They're looking at performance, they're looking at sustainability is a new one. So the green IT concepts, the environmental consciousness comes in as well. And I think it's a big step forward. And the challenge is obviously like when you start a project, I can imagine like customers or as an organization, you're enthusiastic to start using Azure and maybe some other cloud, and you want to get quick results, right? Because that's what we've been talking about for so long, that when you move to cloud, it's like short delivery time, it's fast deployment, it's easy, it's high available, it's secure, it's scalable, all those buzzwords you could say. And we should actually probably take a few steps back and focusing more on emphasizing like how important that foundational architecture is. That it's not about you're going to jump in and we'll revise it in a few months from now, but like really setting out the baseline a little bit. And I know it's a little bit anti-cloud, but actually what we did in the traditional data center, like looking at the broader picture, like what are we going to do in the next 3 to 5 years? That's like traditional data center migrations or implementations. And every now and then, I think we should maybe go back to that model a little bit, like really setting out the journey, the vision. Like this is what we as an organization are going to do in the next 3 to 5 years. Does it mean that it's, again, that big beast of a deployment? Like now we're going to drop everything in cloud and we're going to keep running it for 3 years and then we're going to revise it completely. That's obviously not what I'm saying. It's about the long-term strategy and then still taking those quick wins. Like we're going to migrate infrastructure, we're going to migrate to microservices, but not for everything, not migrating to containers because the whole world runs on containers, right? There need to be like a business case. And that's also what the well-architected framework is trying to help you with. Like make your foundational decisions based on the five different pillars, as Azure calls them, or domains, you could say, and make sure that you max out the best of each and every pillar before you're going to implement it. That's to me what the well-architected framework is about.
Yes, to me, I think you just answered something very, very like niche in the world of the cloud, right? Everybody said serverless. And guess what happened? Serverless is not end of it. Like it's not the ultimate optimization that you can go through. Because I always say this, your 4 lines of optimized code doesn't make sure that your business logic works right. You still
Mhm.
need the Kubernetes, you still need to know how to scale it, still need to know just get the containers right. That's what it's all about. You started as a Unix person, and I think Docker, Kubernetes, whatever it is, it's just an advanced format of the Kubernetes itself. So, like, it's just Unix made look sexier. That's it. So,
Mhm.
I think you just came out with the cloud adoption as well, because cloud transformation, everything was being taught there in
Yep.
that previous answer of the well architected framework. But SRE and the value of treating the operations problem as a software problem, that is something that I really wanted to learn from you, because you're writing a book on SRE as well. And there's a lot of things that are coming up with respect to DevOps and things like that. So, what is a real IT transformation that we need to witness once we are treating an SRE as an operation problems as well as a software engineering problem statement?
Yeah. Well, I got two things there. So first, you mentioned the cloud adoption framework, right? Yeah, I think it's maybe complex. So we just talked about the well-architected framework. Next to that, you got cloud adoption framework from the different vendors. And to me, the cloud adoption is what you would look into before taking steps into cloud. And that's partly what cloud adoption, I mean, you're gonna learn from it, you're gonna adopt it, but maybe you don't know all the potential from it, right? Where the well architected framework to me comes in later in the story, where out of the cloud adoption framework, you're going to take your first onboarding to cloud. You're going to deploy some services, maybe building proof of concepts, running some business critical workloads, but not all of them. Where after running it for a few weeks, a few months, maybe a few years, that's where I think that the well architected framework is a perfect candidate, because it allows you to start from what you have. And like in looking at the Azure case, because that's what I know best, you could also run through an assessment. So you go to the well architected framework website, you go through an assessment. I think it's about 75 questions. And based on the answers, it's going to tell you like, okay, this is where you're already optimizing. This is where you still see a lot of room for improvement. And again, any of those buckets, right? Where cloud adoption is like, to me, you should be an expert in cloud adoption framework before you're going to step into cloud. So that's one thing. And then your second question about site resiliency engineering, SRE, I love it. I mean, I just shared my passion, I think, for DevOps, what got me into DevOps and how I see how customers are using it. But SRE is amazing. And the funny thing is that I started looking into it and talking about it in my Azure classes as well. And a lot of organizations don't really know about it. And I think it's not correct, but that's my view on it, is that like SRE is trying to help organizations with everything they assume cloud would bring, but that cloud is not bringing, like out of its own. So it's obviously heavily focused around running a reliable workload. So you're going to move workloads into cloud, and I think a misconception is that it's just going to run as high available as possible, where there's still a lot of architecting to be done from your perspective as a customer or the partner before that workload is actually running high available. So I remember years ago at a conference, I had a session called Azure is 100% high available, or is it? And it was one of the most popular sessions in my memory, because customers were amazed by it. Like, wait a minute, everybody's been talking about moving to cloud is going to give you high availability, performance, and security. Where now you're really breaking down that we're actually not getting that. And I was like, well, I mean, you get it, but once you start deploying your workloads, you still need to look into it. And it's also where the SRE concept allows you to enable that IT transformation, I think, where if you introduce DevOps, like the full automation, you could now take it to the next level and integrating that reliability engineering, where indeed, as you said, you're going to look at an IT problem from an engineering perspective, like treating an infrastructure problem with software. That's where infrastructure as code comes in, chaos engineering, like purposely injecting faults into your production workloads to just validate and see how they're responding to it. And obviously, ultimately, helping you in keeping workloads running, right? So I see that as a big enabler for IT transformation, where the first wave you could say is like moving to cloud because we want to save money, because we don't want to expand, maintain our own data centers. And I think we're somehow past that for most organizations. Well, now for the next wave, it's all about optimization, where that well-architected framework is one, but then the real technical hands-on part, that's where I think SRE is going to be a big one. And it's nothing new. I mean, Google came up with it more than 10 years ago, but not all organizations are like Google, right? Where it just takes time. They don't have the scale, the size, the budget to like optimize everything to the full 100%. And that's where I think over the last 2-3 years, it's yeah becoming more and more popular to integrate it. The tools are allowing you to integrate SRE in a better way. And then chaos engineering, I think, is going to be like wave number 3, where once it is running, we're going to hammer it, we're going to test it, and we're going to review it again from an engineering perspective, how we can make the platform that we're already using like really maxing out the potential. I think that's going to be a big step.
Sure. So yeah, I think that's a great set of insights that you gave, because a lot of times we forget that, you know what, it's just that evolving culture. It's still the same old automation that we are strategizing. And it's just adding business values. So don't forget that to be added in your entire infrastructure. So now going back to the anti patterns, because you have seen a lot of things as a Unix person, you have seen more amount of chaos, I think so, than me. So I just wanted to realize, what are those DevOps anti-patterns? What is it today when we are having an organizing culture in mind, and there is a DevOps world that is changing? So how should we approach it? So what is it all about today when we have an organization culture that is changing in the world of DevOps? Like everybody is unique in their definition today.
Mm-hmm. Yeah, well, again, a few examples there. So first, it's not about containers. It's not about Kubernetes. I think that's a big one where, well, first of all, there's nothing wrong with it. For the ones who are watching this and they go like, oh my God, Peter is breaking down containers. That's obviously not at all the case. But I've seen so many customers jumping on cloud and integrating with DevOps, integrating infrastructure as code together with application deployments, where DevOps is obviously the instrument to do that, but still lacking in the culture, where I started with at one of your first questions. So to me, one of the anti-patterns is like jumping on the technology, but not fixing everything that comes before the technology. That's one thing. The second one is that, yes, I mean, each and every organization is unique, but on the other side, I think a lot of organizations are less unique than they actually think. Like there's a big reason why cloud vendors like Microsoft and AWS and Google are focusing a lot more on business industries, like creating the Azure for healthcare, Azure for government, and probably some other ones in the future, where there's, I think, like 80-90% of what you're doing as a business in a specific business vertical industry is the same for all of you. I mean, you want to make business in e-commerce, you want to run your business in healthcare, where you got a lot more compliance complexity that you need to take into account. But all other healthcare organizations within the same area, within the same region, they're facing the same challenges. So why not learning from each other? Why not maybe even partnering with each other and establishing that collaboration? Because if you look back at the success of DevOps, what I mentioned earlier is really that collaboration. It's grabbing everything that's nice from the automation perspective, but integrating that culture as well. And once you have that part, I think everything else that's like specifically technical or so specific for your organization, it's just going to help you. And an analogy that I always like to talk about in like discussing DevOps, setting the scene around culture and collaboration, is if you look at like the car industry, right? Where, I mean, we all like different cars, different brands. There's a lot of different types available. But once you start looking into like what are the different parts in the car itself, they're technically coming from all over the place. I think, I mean, for the ones who follow me on Facebook, they probably know that I like a Jeep. And I don't really know why, but to me, it's partly bringing me back to like the movies I've seen as a kid, where like the U.S. Army is coming over in Second World War and driving around with their Jeeps, and those cars were like super ruggedized, right? You could go uphill, downhill, through the swamps, through anything, and those cars would still run fine. And I think that's, to me at least, where it started. On the other side, I also like the fast cars. My demo project that I always use in my trainings is called the fast car case, just because I like fast cars. Not sure if I really want to own one or ever driving one, but it's just like, I think that boys thing inside of you, that when you see one of those muscle cars passing by, or you hear them or you feel them, that's like the experience, right? But I got me a Jeep car a couple of years ago. The smallest version they have, Jeep Renegade. And the funny thing was, when I was still living in Belgium, that there was like nothing American about that car, besides maybe the little logo and the brand of the company. But everything else inside the car was like coming from like maybe 3,000 different car parts vendors. And the car itself was assembled in Italy. So um, just that as an example, like you could be so passionate about something where you start forgetting about the broader picture. And in the end, if you go back to the core of DevOps, it's again providing value to your business or your customers, your partners, by working together. And why not only working together as the developer and the ops team? And actually, to me, it's a lot more than that, because you also have the project managers, you have the business stakeholders, you got the marketing teams, you got the sales teams. So there's a lot more business departments involved in successfully implementing and realizing DevOps. But on the other side, don't just focus on your little island. Like look at how other companies were doing it. Maybe even looking at how your competitors were doing it, because there's a reason why your competitors might be more successful, because maybe they adopted DevOps a lot better than you did. Maybe they already figured out the well-architected framework concepts. Maybe they're already using site resilience engineering, which means they are facing a lot less downtime, which means they're, again, running a lot more optimized. So I think that's at least one anti-pattern, that it's not just about you anymore. Although, again, I understand that there are specifics for each and every organization. But overall, I think that's like maybe 10, 15% of that. Compliance is something that we all see no matter where you are in the world. The compliance regulations are different, but compliance is something that you all need. High availability, performance, security, to me, again, those are the standards. And on the other side, the other anti-pattern is like, don't focus too much on a specific workload type. Like again, using containers as an easy example, because it's been super booming the last 2-3 years, but there's a world outside of containers. Like maybe you're focusing too much on moving something into a container workload, where you're forgetting about like serverless. Like you could use Azure Functions, Lambda on AWS, and it's going to give you like another potential to work with, right? So that's where I think looking at the broader spectrum, like what is the core business value that we want to bring into our organization? And starting from there, looking at the high availability, performance characteristics, the security aspect, obviously the cost aspect as well. And from there, like opening or being a bit more open-minded. Like it's not we need to move to cloud because of containers. It's we need to move to cloud because of the business value. And what brings in the business value, that's going to be the technical decision factor. But not starting from, we're going to jump to cloud, we're going to deploy containers just because of deploying containers. It's the same with virtual machines, right? Where there's nothing wrong with running virtual machines in cloud. But on the other side, it's typically still one of the most expensive components, because they're, first of all, expensive to run in cloud. But next to that, they're also more expensive from a maintenance perspective, because you still need a technical team to watch over, where the more you're going to shift to platform services, to serverless architecture, the less infrastructure you need to manage, you need to maintain, which also means that it's a lot easier to keep up that continuous motion of publishing new software. And that brings me back to the starting point where DevOps is probably the enabler for a lot of that.
Sure. I think it's the same way. Yes. There is no measure to say, you are 100% secure. There's no metric to say, this is what I require in the world of dev. But but to me, yes, I feel that, there are some standards that it has been said, but it's told as a metric. I don't know about it. So I still
Mhm.
remember one of your talks where you talked about MTTR, MTTF, and things like that. So I would love to ask, like, is there a metric to measure the security and the reliability of an infrastructure? And should they really do that MBA wala research thing, or what is it all about when they are metricing out?
Yeah. Um, well, I think measuring security reliability, there's two different parts on that, right? So I'll start with reliability because I think it's a lot easier and a lot more common. Some of the metrics, well, you got SLAs, service level agreements, where interesting enough, I don't think they really fit in that category. On the other side, what do you have? And I'll explain that later on. What you have is SLIs, SLO, service level objectives, service level indicators. In short, what does it mean out of those metrics? It's building out your environment, the high availability, the reliability, but mapping it with what your business is looking for. So going back to the traditional on-prem data center stories, right? I remember, and I was part of an IT organization, so part of my role, although it was technical, was also jumping on like RFPs, organizing technical pre-sales meetings with customers, and evangelizing the platform that you would build for them, right? And if I look back at like how we deployed VMware, Hyper-V, physical servers, physical storage, it was always about 100% high availability for everything. So as you said, you would deploy a collection of redundant storage, integrating storage replication, where the company I worked for was one of the prime partners around NetApp storage. Brilliant solution, but maybe a little bit overkill for a lot of organizations, right? Where next to that with VMware, it's about the same. Hyper-V, honestly, is about the same, where you're going to build out your physical servers, you're going to run virtual machines, and you're going to rely on vMotion, you're going to rely on the Hyper-V replica, allowing you to synchronize, replicate VMs from one end to the other, and all moving towards running the workloads as high available as possible. Where on the other side, not all workloads need to be high available, or not all workload need to be as high available as all the other ones. I remember a customer scenario, and I'm sharing that every single week in a training, where one of the so-called business critical workloads was like a sandwich ordering web page. So what they were running internally was a website allowing the employees to order food for lunch. So you could come in at 9 o'clock and until like let's say 11:30, you could order your sandwiches and soup. That's a business critical workload. But honestly, when you ordered your sandwich and the canteen or the cafeteria is closed at 1 o'clock, maybe 1:30, that workload doesn't need to run anymore. So you basically give yourself a maintenance window from, let's say, 2 in the afternoon till like 6 in the morning to fix the problem if that sandwich ordering system is not running. And worst case, I mean, it's a sandwich ordering system, right? Now, looking at where that application was running, it was running on the same VMware backend where their prime business SAP e-commerce backend was running on. So mapping SAP complexity, the SAP reliability requirements, that's for them was the starting point for building out that high available VMware environment with expensive storage, expensive servers, firewalls, everything. And then adding that little, I think, not super crucial business workload that's called a sandwich ordering system running on that same backend. That was to me mind blowing. Like maybe we're doing something wrong. And obviously it's not wrong because for them it was like, well, we already have that high available environment. So why should we not use it, right? But then looking in later on and after so many years going back to that customer where they started their journey into cloud, their initial idea was again like we need to move everything to cloud and everything needs to be high available and we're going to move virtual machines and everything. And that's where I pushed back. Like, first start with doing your homework. What is the reliability requirement for each and every of your workloads? Based on that, you can decide, do we still need to use high available, expensive virtual machine clusters? Can we maybe move to a web app service? Can we move to a SQL Azure database scenario? Things like that, right? Where it doesn't need to be that expensive, complex clustering scenario anymore. So that's where the RPO, RTO comes in as one of the, I would say, common metrics around reliability, because you need to figure out like how reliable does my workload need to be? That's the SLI and SLO. But also, what if there's an outage? How much time do we need to fix that problem? And that's what RPO and RTO gives you. And then you also have a few other ones coming to mind is like MTTF, mean time to failure, like how long does it take before we actually face an outage? The MTTR, mean time to recovery, or mean time to repair, where there's a fine notion between fixing a problem and or fixing a software problem, you could say, and fixing a physical hardware problem. So that's where the repair is a little bit closer to the physical aspect, and the recovery is a lot more on the software side. And then another interesting one is MTBF, the mean time between failures, because it could give you some indication as an organization. If you see an outage of your business workload, like every Monday morning, 6 o'clock, the same problem comes up, it probably means that or there's something wrong with the workload, or there's something wrong with the underlying infrastructure, or maybe you're running the wrong tasks in automation or anything. So that's where you could pinpoint quite accurately like what are the metrics we need to watch over. Security, I think, is a little bit harder because you got so many different levels around security. Are you talking about network security, where I think the metric is like how many um, attacks do you see coming in on the outside of the firewall, for example? But it's also about identity, like how many failed logon attempts are we seeing? So I think that's a little bit harder to measure, or at least not as clearly defined as reliability one. Does it mean that you cannot measure it? Obviously not. I mean, um, like anything else in the world, I think it comes back to monitoring it, defining again what works for your organization, and not just following like always going for the maximum. And like going back to the first acronym I mentioned, SLAs. To me, SLAs are less important to work with. Does it mean that they're useless? Not at all. But an SLA is not going to help you as an organization from a technical perspective. Because what an SLA does is just giving you, I always explain it as some legal instrument to allow you to complain if something is not working as it should be. Like in the Azure case, like any other cloud vendor and technically any service provider, you could say, we're going to provide you a number. Like our web app service workload is going to be high available, like the SLA is 99.95, which means it can be down for about 20 minutes a month before you can start complaining. That's my easy way into it, right? If it's down for more than 20 minutes in this example, that's where you can start complaining. Like, hey, vendor, can you please fix the problem? And the other thing is that there's a penalty typically as a solution for the problem. But if you look at the potential data loss, the risk of losing customers, the risk of not having your workload, that compensation, like the penalty you get back from your service provider, it's not going to keep your CFO happy, and it's not going to keep the CTO happy. So that's where I think it's a lot more important to focus on like the RPO, RTO, SLO, SLI specifically for your workloads within your organization. And yes, obviously also knowing what the foreseen SLA is from the vendor. If you come in, like my business critical workload needs to be 99.99, like the 4.9 industry standard, I think, high available. And we're going to deploy it on some platform with some characteristics where now the vendor tells you like, no matter what, but with this kind of architecture, we can never reach that 4.9 high availability, you already know that you're doing it wrong, right? So it obviously goes hand in hand, but it should not be a goal on its own. I think that's the good way to explain it.
Sure, I think there is a way in which customers are perceiving it in a different way, right? They don't understand what's going in the engineering team. If it's an edtech startup, students need to see it every single day. So that's how it is. So how do you think that we are perceiving technology today? Because a lot of times when I think of scaling this, scaling that, or just run more pods, run more clusters. That doesn't work to a greater extent. But building a scalable, secure, and account environment today is a challenge also because
Mhm.
consumers are increasing. There is a lot of challenge that comes up. So there is a lot of things coming up today. So how do we need to approach this consumer demand as well as, of course, consumer doesn't understand the engineering that's going behind that product, so and maintaining that secure, reliable, and whatsoever infrastructure availability to be available for the consumer. So what is it all about when we're approaching the secure, reliable, and sound infrastructures today?
Well, it's a great question. I think it maps with well, something I already mentioned earlier, that um, it's complex. I mean, you need to, as an organization, you need to focus on building your workload. You need to focus on building it out high available, secure. And on the other side, there's this notion, this misconception that cloud is going to give everything of that out of the box, right? Where I remember the marketing pitch for cloud a long time ago was it's high available, it's secure, and it's cost efficient. And I think we can all agree, at least for larger enterprise environments, that yes, it was more secure, but they didn't always trust it, at least not in the early days, or some even not still today. It is high available, but yes, if you architect your part of the cloud in the correct way, and it's also positioned as some sort of commodity, right? Where we all know that we still need cloud solution architects, we need a well architected framework, we need a cloud adoption framework, which means that it's not all that easy that straightforward to move into. Now, adding all those complexities into one big bucket, together with, and I like to use the example how unfortunate it is, but even if you look at like the shock in the world like 2 years and a half ago with COVID and the pandemic, I think that's where a lot of organizations actually find out that what they've been using, what they've been running, been building for so long was not always helping them. It worked great for years, but then yeah, overnight, I mean, the pandemic was there, and overnight, in a lot of parts in the world, you were not allowed to go to the office anymore. But going to the office was like a huge part of the security boundary because that's what organizations did, allowing users, allowing um, customers to come in, connecting to the so trusted corporate network. And everything that was like happening outside of that network was by design untrusted, it was unsecure. Where now, if you cannot connect to the office anymore, yeah, you cannot reach your workload anymore. And yes, I know obviously we do have VPN, but deploying VPN from, let's say, your 3,000 IT and developers teams all the way to 30,000, 50,000, or even in Microsoft's case, like 200 plus thousand employees, and all enabling them for VPN overnight, it's just not doable. So that's again where I think there's some lesson learned there. That first of all, you don't need to go to the office, but that's less important because it's more important to know that your um, office boundary is not your security boundary. The world is a lot larger than connecting from within the office. The same with scalability, high availability. Like, why would you still spend money on building out your own trusted, high available, super secured data center if you know that that's like the baseline that the cloud vendors are giving you? So I think some organizations need to take again a few steps back, what I mentioned earlier, and really digging into the capabilities of the cloud environment, and then mapping that with like the customers in the end. And I remember from my system engineering, my technical pre-sales days, that in so many cases when like your like a technical audience connecting to your customer. In a lot of cases, you start from your comfort zone, being the technology, right? Where a customer in the end doesn't care. They want to run an application. They want to see value for the business. I mean, there we are again with DevOps, right? But they don't, honestly, I think they don't care about how you're going to run that, I don't know, the next e-commerce platform. If it's going to run on Azure, AWS, Google Cloud, on-prem data centers. No, what the business is looking for is a high available, scalable, secured e-commerce environment. And where it runs, I think it's becoming less important because you don't have a message. The only thing is like we have customers, they want to go to a website, they want to order stuff, and we need to help them optimizing that ordering process by a nice looking website, by mobile phone integration, easy payment gateways, clear shipment information, everything else. And then maybe after you sold the product, like maybe trying to bring them back in and ordering something new. That's like where the value comes in. How it runs, the tooling you're using to deploy it, to maintain it, to keep it reliable. The business has no message onto it. And I think it's also a shift in the IT transformation that you mentioned earlier, that maybe cloud is going to allow us to focus less on the technical details and moving a lot more on the components that are important. Like move your workload to cloud XYZ using this kind of architecture. And we have the guarantee, looking at historical information, how other similar customers have been using the platform, that your workload will run fine. I think we need to maybe try and move more in that solutioning scenario or solution conversation, and a little bit less, or maybe a lot less, focusing on the technical details of a solution.
Yeah, I really wanted to ask you the questions on tools for SRE. And also, there's a lot. There's a lot beyond that comfort zone of just sitting and looking at the screen, that 99.99% four nines availability. That's going to be impractical to a greater extent. But I wanted to know one thing. I wanted to realize what's the philosophy behind building a great SRE team, because fundamentally it's not the tools, it's not the matrices that are going to come over a long run. But I wanted to understand what is it all about when we are philosophically talking about building a great SRE team.
Mhm. Um, well, I think there's a couple of things. So first of all, you need to you need to know what you're doing. I think that's clear. Next to that, you need to have a passion for fixing issues. Like really grab it, dig in, and fix it. Next to that, there's the team collaboration again. That's I think also important. That when you're part of that SRE team, the ultimate goal is running your workloads as reliable as possible or as reliable as needed for the organization. But like the easy example from the past is like, oh, it's 5 o'clock, time to go home, and we'll look into fixing the problem tomorrow. Where I think that's the wrong mindset. If you see that problem coming up, grab it, dig in, and don't let go until you fix the problem. Next to that, it's not only about fixing the problem like it is done right now, but also look back and look into the future like, okay, this is what happened. Run your workload analysis, like dig in the root cause analysis and finding like what happened. And it's also where like the blameless retrospects are coming in, which means that if you find the root cause as an individual or as a team, that you should not pinpoint anyone. Like the funny example I can bring up there is what happened with SolarWinds, right? Like last year, I think summertime, where they exposed like the default admin username and password, and that's what attackers were misusing to break in a lot of different organizations. And then eventually the company SolarWinds said like, oh my God, it's not our fault. We had like an someone working in an internship. So they were immediately pinpointing like, oh, well, this person didn't have enough experience and that's what happened. And they should not do that, because in the end, you're all part of the same team. You're working towards the same goal, and that's having that ultimate reliability for that specific workload. So pinpointing anyone, like identifying victims, it's not going to help you. It's actually breaking down the whole DevOps culture again, where if you're telling me like, well, it's your fault that this or that is not working fine, then yeah, I'm gonna push back and I'm gonna hold back on stepping in for maybe the next project because you don't trust me anymore, right? And that's where I think we need to watch out as an industry that we're not gonna pinpoint anyone. It's really about embracing that collaboration. It's the same with like the partner customer relationship where when something goes wrong, it's always the partner telling the customer like, "Oh, but you didn't provide me all the details." Where the customer goes like, "Well, partner, I'm paying you a lot of money, so you need to take responsibility to go out and fix it." Where it's again about that collaboration from the start, like share all the details, look at the same future, try to um, come up with common ground, like finding the middle point, and move that into your project. I think that's important. And then zooming in a little bit more again on the site reliability aspect or the SRE role, how it could help in that IT transformation. It's it's starting from knowing what your business is looking for. So it's again not just transforming for the fun of transforming. I think there must be a really good goal in why you're doing it and how you're going to do it. Then also looking at the not 100% high availability anymore, but what is required for your organization, which definitely is going to enable cloud migrations a lot. Because I'm pretty sure, and I heard from customers in my workshops that they're not running specific workloads on cloud because they are afraid that it's less secure, because it's less controllable, because it's less touchable, like everything with serverless and microservices. And that's the reason why they're not jumping on cloud, where once you can convince them that cloud gives you that baseline high availability, adding that architect framework on top of it, integrating your SRE mindset, knowing that you have a strong team with engineering mindset, with developers, with technical tasks, with development tasks. And whenever something goes wrong, like the team is joining forces to fix that problem. And not only once, but fixing the problem in the long run. I think that's ultimately what SRE is about. And then the tooling question you had, I think to me it starts with monitoring and observability. Like if I remember I had a phrase at some point that what you don't see, you don't know. And what I mean by that is that if you're not monitoring your environments, if you're not watching over the health of your systems, there's no way you can make decisions. If you don't know that all your servers are running at like, I don't know, 95% CPU all the time, how could you make a decision to deploy more servers? How could you decide on migrating away from VMs? Where on the other side, if you have a workload running on a virtual machine where the average CPU load or memory consumption or any other metric that you want to read out is like super low, like 5%, 10%, 15%, to me, that would be a perfect candidate for maybe moving it into an app service layer, moving it into a container workload, and getting rid of those complex, expensive virtual machines. But it's again starting from the monitoring and observability. Based on that, you're going to read out the metrics, you're going to map them with the business needs, and that's where you're going to define your goals. And not only from a high available perspective, but looking at all the different components. I think that's an important one as well.
Sure, I think that's a great amount of insights because a lot of times SRE teams don't evolve in a day. Don't worry about it. You can't have hundreds of tools plugged into your Kubernetes cluster and say, you know what, we have the most amazing monitoring and everything about our infrastructure. So yeah, I think that's about it. Yes, we have a lot of things to be covered about scaling platforms because we say Kubernetes is this, Kubernetes is that, but exactly to be very frank with you, Kubernetes is also honestly not that secure until you don't know how to make it secure. So now my question is all about like the scaling platforms today. I feel that most of the times I feel that it's just the trade-off that we play between what is getting developed and what is being secured as well, because there's a lot of changes that comes in one version to other. What is to be patched, what is to be unpatched. a lot of things are coming up. What is it all about when we talk about trade-offs in the scaling platforms, and also
Mhm.
all about that infrastructure that we need to learn about? Because a lot of times I feel that you're a you're a member of technical staff and you still don't know what's the caching strategy that has been there. I say external caching is being taken care by this company, that company, and I'm like, why did you outsource it to the third party guy if you don't know what is happening there? Because I do bounties and I feel that API keys are already down there in the world today, and I can crack into any application and get them. So, what is it all about when you are playing the trade-off of the scaling platforms, performance or the availability versus the trend that is going on with respect to learning the infrastructure? So, how should an
Mhm.
engineer behave an engineer? That's the whole point.
Um, well, infrastructure, I think, is a difficult one. Like you mentioned, there's like so many different complex components, a lot of things you need to take into account when building your infrastructure, and it's not even where you're going to deploy it, right? So you start with um, yeah, building that foundational layer again. I think is important. Knowing like what can we achieve, knowing what do we need to achieve. But overall, if you look at like cloud, I think in my opinion, that's the beauty about cloud, is that you can forget about a lot of the infrastructure complexities. Does it mean that it's a lot easier, that it's straightforward, that you should not look into it? That's obviously not the message. That's again where like the what we already talked about, the well-architected framework, cloud adoption framework are again the baseline for knowing what you're gonna do. On the other side, and that's where again I like to use virtual machines. Running a VM in cloud or running a VM on-prem, it's technically the same thing. It's still that virtual machine. You need to look into the high availability, identity, security, the storage interaction, the firewall communication, everything else. And that's where if you step away from virtual machines, it's like a huge backlog, you could say, like a heavy weight is literally dropping off your shoulders. But then there's that misconception again coming in that if you're not running virtual machines like containers or platform services, that you don't have to worry about all that anymore. And that's also not at all the case. Like again, containers, we already talked about it several times, but like you said, containers are complex. When you run a Kubernetes environment, you really need to know what you're doing before, sorry, you're going to run it in a secured way. Where going back to one of the first topics around DevOps, I'm pretty sure that DevOps can be an enabler towards optimization on that end, because you're going to build infrastructure as code using Azure templates, Bicep language, Terraform maybe for multi-cloud, cloud formation on AWS. And that's where you're going to start on looking into that automation process, where building that infrastructure is now nothing more than running a script, right? Or running a DevOps pipeline. But next to that, it's also helping you in heavily integrating security, because if you know that your team is not playing with the buttons and clicking around anymore, it means that they're typically less vulnerable for making mistakes. And they're also moving towards standardization. And that's going to help you in like integrating security a lot better, moving towards standard infrastructure where it might just be a subset of your workload complexity anymore. And then leveraging on again, yeah, the powers of cloud, like the observability. And again, I can mainly talk about Azure, but looking at like Azure Monitor, log analytics, application insights, integrating with Prometheus, Grafana, those kind of tools that they're now available as a cloud service. So you don't have to go through a third-party tool or a third-party cloud anymore. You could all run this from within that same cloud environment. On the other side, we're not excluding anything. So even using Azure services would help you monitoring, integrating with third-party clouds. And that also goes back to the other question where I talked about the Jeep and the cars, right? Where in the end, again, the baseline is we have an application, we have a workload, and we want to run it with all dependencies, high availability, reliability, scalability, security, performance, anything. That's what it's all about. And how you're going to run it, where you're going to run it, how you're going to monitor and measure it. I think that should be less important. And maybe that's where I think as an industry we could also help you a little bit in like making it a lot more straightforward, like injecting assumptions, injecting default policies. Like if you deploy a web application and a database, why would you still need to figure out the firewall configuration? I think it would be awesome if the cloud platform would be smarter in detecting like, oh, you're running a web workload, you're trying to connect to a database, and that's like the only communication you need. Why would you need to become a firewall expert if you're deploying a 2, 3 tier workload? We should try and somehow accept the standardization. A lot of opportunities there.
Yeah, I know that. I know that. So now my question is all about like we have a lot of things. So Azure DevOps is and SaaS too, because it's on premises, you can just get everything back. But to me, a lot of things just fall behind that policy as a code and the code and the sorry, policy as a code and the governance as a code. To me, that's what really bothers me a lot. So how is the tech going to be influential for the tomorrow's world in the DevSecOps aspect? And also, what is an existing trade-off that we need to work on today?
Well, it goes a bit hand in hand with the previous topic, right? Where governance as code, policy as code, almost anything as code nowadays. Again, first of all, the aspect of the fact that it is based on something as code, I think is always a good step forward. It allows you to integrate automation. It allows you to do better DevOps. It allows you to watch over what's happening and also helping you in failing fast, but also fixing fast. Like the reliability aspect of it. If something goes wrong in a specific cloud region, you can easily redeploy something in a different region, and the downtime will be a lot shorter, right? So next to that, and I think that it maps a bit with the example I shared about making the cloud platform smarter. Like if we know that you're connecting from a specific part in the world, knowing that as an organization you're active in a specific industry like insurance companies, finance, healthcare, government, I think there's an opportunity where the cloud environments could provide you a lot of those standardized baselines. Like SOX compliance is SOX compliance. There's no way around it. So why would you as an organization need to look in all the details? I think we, as a cloud vendor, we should look into making it a lot more straightforward. Like if you're going to use this kind of workload type, running a specific service, we already going to provide you a catalog, a setting, a list of policies as code that make your workload SOX compliance, HIPAA compliant, any of those ones, and actually trying to yes, step a little bit away, or asking you as an organization to step away from the technical complexities that comes with it, like detecting firewall communication, detecting use cases, just out of the fact that you're going to deploy different service components, different workload components, and like learning from the intelligence we probably already have, and locking down everything else. So the not just looking at policies as code from a governance perspective, but also integrating policies that it's excluding a lot of the services, a lot of the characteristics and capabilities until you're going to use them. Does that make sense? Like having it less open, but maybe more restrictive from the start, maybe making it a little bit harder to just click around and enable more services, knowing that it's also exposing a potential risk by doing that, where you need to go through a few cycles and a few steps before you can actually use that next service, not just because it's cool or because the whole world talks about it, but really because you know what's the impact, what's the benefit for using that service as my organization. So finding that balance between specific services for your specific organization, and next to that, mapping it with the cloud as a commodity. I think that's where the industry could probably optimize a little bit more for the future.
Yeah, that's true because back then there was no Dependbot or Microsoft Defender or anything that you could just integrate with your GitHub just to get optimized in terms of that security scans, the stats tools, whatnot. Today it's just accessible. Just go grab the tool, or else like just try building your own because there are a team of engineers who have their own open source hustle that's going on in the back end. Like they'll just help you for sure. I think thank you so much, Peter, sir, for giving such grateful insights because my
My
customers
pleasure.
would obviously love to listen back to all of your insights that you have given. Thank you so much, sir.
My pleasure. A lot of really good questions. So I think you spent quite some time on thinking about them and mapping them in, like, what can my audience, like your audience, use, looking a little bit at the future. So but there's actually one last thing I could share. So you probably know that I've been working on a book around SRE. It's actually called The Art of Implementing SRE in Azure. So what I'm going to do for your listeners, the ones who are watching over the podcast, the book is coming out in probably within the next 4 to 6 weeks. Um, so the ones who are watching or listening to the podcast, I would say reach out in the next coming weeks. Maybe check back with Vishwas. He's probably going to announce it at some point when the book is available. And I think we can give away a few copies. I think that's like the least I can do as well, giving you something back for inviting me for your podcast. So that's my promise. I'm gonna
Sure.
make that happen.
Thank you so much for that. That means a lot. That means a lot. And thank you so much, sir, for such great support. And yeah, of course, folks, you know who to just reach back to. Reach back to me. We can just get some books just for you. So thank you so much, Peter, sir. Means a lot. I'll